Today my topic is about automatic data center and service deployments based on artifacts. So 2 keywords in my topic. First one is automatic, second one is artifacts. First, let me introduce myself. I started my career as a Java EE application server developer. Then I started working on the virtualization of software-defined data center. And after I joined Alibaba, I'm in the technical infrastructure team. We managed the infrastructure for the Alibaba company for like cloud products and also the e-commerce platform. So you can see I'm actually a software guy, and it is quite different from the other people in our team because the other people are most working on the hardware part. Let's think about how to deploy a data center. In the early days of Alibaba, actually we built a data center just from the data center itself, the racks, the network, the servers. So mostly we just think about like the power saving and how can we put more servers in the data center. But later when we start the cloud service, it's a totally different thing because cloud service is actually something like a software offering. And when we want to provide like the elastic computing or storage service, it has many requirements for the data centers. So then we find we have many difficulties to deploy a data center. First, we need to think about capacity planning. Before we provide cloud service, the capacity planning is actually quite, it is quite simple because we just think about how many workloads we need to provide for our data center. So we just plan how many servers, how many switches, and how many racks we need. Then we just need to think about how to place the servers because we have different kind of machines. Like we have Intel-based machines, we have also ARM-based machines. And then we need to think about how to cable the networks, and then how to bootstrap the network, and then to initialize all the operating systems. And finally, we came to the software service bootstrap. You can see in this procedure, we actually have different teams working together to deploy a data center. But first, when we just deploy a data center in like 1 month or 2 months, it is just fine. But later, when we provide cloud service, we need to initialize like tens or even hundreds of data center in a month or later in a week. It is quite a challenge for us. So we want to provide something just to do capacity planning only by the business requirements. Like if there is a business opportunity in somewhere in the world, we can easy to do the capacity planning. We know how many physical servers we need, and the second goal is to just do the automatic deployment because we want to initialize everything without people because we have a very small team in our department. And third one is auto-healing for hardware failures because when you have like millions of servers, actually there will be always hardware failures. Before our solution provided, actually we need people to do the recovery. So when there are several data centers deployed at the same time, it will be very busy for that team. So to achieve our goal, we provide a solution. Actually, 2 most important things. The first one is an immutable bare metal infrastructure, and the second one is just to describe the data center with artifacts. So today my topic is actually most part about these 2 points. The first one is how to make an immutable bare metal infrastructure. Let's just go back to the traditional deployment method. The traditional deployment method is just like we play with the building blocks. We start from the foundation service, like we start from the data center itself, then the racks, then the network devices, then the cable, then the operating system. And just step by step, we have a standard workflow to initialize everything. And we can build a very good delivery pipeline so we can make sure that everything is working as we expected. The good point for this traditional deployment method is it's very easy to learn for the beginners because we have different experts in different areas, and we can make them to work together. We can just hire some good project managers to manage a complex project and to make all these people work together. But there are also bad points. The first one is it's always impossible to roll back, which means that when we deploy, for example, when we deploy the operating system, then we start to deploy the services. And after we deploy services, we figure out we need to do something before this step, but it is impossible for us to roll back. We have to just remove everything and go to the very beginning and do the things again. Of course, we have tried to optimize this step with workflows, but because there are too many steps, it is always difficult to do optimization to make it perfect. And second is the step is very difficult to update, which means that even if we have successfully delivered a data center with this kind of method, it is always very difficult for us to update the data center, especially for the firmware, like the operating system, the system service, because all this service will impact the servers itself, and so it always impacts the application service on the top. So normally, in this kind of methodology, after we delivered a data center, normally we won't update it. But in cloud offering, because we have so many data centers, we need to make all of them just the same. So the old data centers, we have to update them. And the third one is it's very difficult to lock down because we have to ship hundreds of data centers. So we need to make a baseline for our data center so that we can make sure for the new data centers, it's just exactly the same as we expected. With the traditional methodology, actually, we have tried different ways to optimize them. But these 3 points, after we have tried years, we cannot fix them. So we came to a better solution. Let's lock it down. This idea just actually from the software services. In the software services, actually, we already have this kind of technologies that's like Docker, just like the virtualization technology. We can make a baseline for everything, and we can deploy it over and over again with the same manner. The most important thing in this solution is that, first, to make the configuration before deployment. Because in the traditional deployment method, when we do a deployment workflow, actually, in each step, we will first deliver the binary, then second, do the configuration. For example, when we delivered a network device, we first just initialize it, then we do the configuration for the network device. And for the operating system, actually, we first install the operating system, then we do the system configuration. And for the software service, it's almost the same method. If we can put the configuration before the deployment, which means that we can know what we want before we do the deployment. That will be much easier for us to lock it down because we can put all the expectation configuration before we do the deployment. And the second is make the runtime state-driven. State-driven means that all the workflow is not triggered by people, but actually triggered by the engine itself. In the traditional method, actually, we need some experts to trigger the workflow step by step. If there is any failure, we have to have some experts to look into the failures and find out a way to recover it. But actually, in software environment, we can make it state-driven, means that we can just use the software engine to move the state from one to another. A very good example is Kubernetes, which is quite popular these days. If you have tried Kubernetes, you'll find if you use Kubernetes, you can just write a configuration file first, and then you input the configuration file. Then the Kubernetes itself will move itself with state-driven behaviors. So that's a better solution we have to think about. So in an immutable infrastructure, the most important thing is to do the deployment with images. The images is actually like this. We just put binary and configuration together to make an image. And when we try to use it, we just copy the image and run the image. So the most important thing is we need to think about is how to separate the binary and the configuration at the beginning, and then how we to mix them together in the image building process. And we want to remove all the complexity in the runtime, because before this kind of methodology, we have a lot of work to make the software run at runtime, because there are many, like the system requirements, like the dependencies we need to handle in the runtime. But in this methodology, actually we put all this complexity into the image build process. The concept description of image build process is like this. The image builder is a software service. The working process is quite simple. It reads the runtime configuration first, then gets the build number from the configuration file, then fetch the build from build repository. There are always different kinds of build repository, like for Dockers, we will have Docker registry. And actually, we are not using Docker for our infrastructure, so we have like some build service. Then the image builder builds the image and puts the image into the image caches. The image cache is a distributed service in each data center. So you can see that the build repository and runtime configuration is a global service, which means we have only one service in the world. And the image builder is a region service, which means it will cover the regions, like we have several regions in the United States, several regions in Europe, and we have different regions. And the image caches, actually, it is serviced in the data center level. In each data center, we will have an image cache service. And then the runtime servers, actually, we have some local agents we named as downloader. It will fetch the image from the image caches. So in this process, you can see that we just build image in the region level, then dispatch the image to the data center level, and every server will fetch the image it needs and run it in a local manner. So we make it as simple as possible. When we talk about immutable infrastructure, especially these days, we are talking about like the Docker, like the virtualization world. Actually, we already have some practice in the open source world for the immutable infrastructure. Immutable infrastructure is actually just treated like a black box. The user never know what happens in the black box. What the user know is just how to write the configurations, how to do the changes. And the one most important idea here is that you should never write the change in the description file. You should describe the states you want in the description file, because changes is very difficult to maintain. Like we normally, in our statistics for a server, we might have hundreds of changes a week. If we put every change in the description file, it is very difficult for us to validate the changes. And it's also very difficult for us just to evaluate what will it change in the runtime. Because actually, in a distributed system, the ground truth might be quite different from what you expected. So here, we need to put the state description for everything and put it in the black box. Then we'll get the result. So this is how it works, like for the Docker Swarm, for the Kubernetes, for the virtualization. Actually, it's just working the same way. The only difference is that if we want to build a bare metal environment, there is a very different thing, is the operating system. Because for software service, I have already described how we make the image builder. But for the operating system, it's a quite different way. So after we have tried different solutions, finally we came to an idea to make a provisioning service. It is quite similar to the image build service. We treat the operating system base image just similar like the service binaries. We store them in actually a storage service, and it means that we boot the server from the network and load the operating system base image from remote service. And the second is that we put all the things, like all we needed for the system administrator to change on the OS into configuration files. Here, actually, we use YAML format to describe all the changes. Or I should say, to describe the final state of the operating system. We have tried different language to describe it, but finally we figured out YAML might be the best solution we have ever found. So the provisioning service is just working like the image build service. It will load the operating system configuration file first, and then read which base image it needs, and then loads the base image from the remote service, then boots the server from network, and after the network service, after the operating system service is booted, we have an agent inside the operating system. We name it as Osman, the manager for operating system. It will get the configuration file for this server and then initialize everything as we expected. Then the next step is just as before, we initialize all the software service, just like with the similar way. The only difference is that we mix the service binary and service configuration in the image builder. But for the operating system, actually, we initialize the configuration from the agent. OK, so in this way, we build an immutable infrastructure in a bare metal environment. and we make it a very good deployment pipeline. So the next thing actually is that how to describe the data center with artifacts. Because when we do capacity planning, there are many things we need to think about. We need to think about the business requirement, for example, we open a new data center. We need to think about what kind of service we want to provide in this data center. Normally, this decision is made by the business people. And the second thing is what capacity will this data center provide? And finally, how many physical resources we need in the data center. So we separate the capacity planning phase into two phases. First one, we name it as business planning phase. The second one is delivery planning phase. In business planning phase, the business people will input all the requirements, the business capacity requirements. And in this phase, what we provide is we categorize all the software services into products. And we do something to make the service mirror unified. And the third one is we made some network baseline, which means we can just let the business people to choose, like, you need a high-speed network or need the cheapest network, just like something like you buy something in the supermarket, you can just choose things. And in the delivery planning phase, actually the delivery planning phase is more focused on the real world. Like, we need to do IDC planning, which means we need to think about how much room we have in the data center and how to place the racks, and how we configure the network configurations. And finally, just as I described before, in the immutable infrastructure, we need to generate all the configuration files for the operating system and service. To achieve this method, we need to define some concepts. So the next step of my topic is I will just introduce our approach for this kind of method. We have three concepts in our artifacts for software services. The first one is product. Product is visible for the business people, so it's the final deliverable for them. And second is service. Service is actually the real concept for the software developers. It's the software deployed on a cluster. So normally it is a distributed service. And the third one is application. The application is the real thing run on the server. Normally, we will map one application to one kind of process in a server. Like we have a Tomcat process. Normally, we'll model the Tomcat service in an application. But if we provide like a web service we might model it into a service, and we model the Tomcat itself as the application. So that's the concept we have. So let's just dive into each concept. So I will introduce what we have for this concept. The first one is product. The product concept is quite simple for the end users. The products are composed by the services. It means that if we want to provide a product, normally we need several services to make a real product. And the one important thing in the product is to describe the deployment topology. Because even if the software service are the same, we deploy it with different deployments topology. actually will get different products. And products also describe the exposed features, like what we will have for the end users. For example, like we have elastic compute service in Alibaba Cloud. So this is a product because this is visible for the end users. And when the business people to make a plan, they will think about like what kind of product they want to provide in that region. So this kind of thing, we make it as a product. And in product, because it is composed by services, so for the service described in the product, we need an unified ID or name to reference to a real service, because we have service in our concept. And the second thing is the version, because for every software service, actually we'll have different kind of versions. And because in our company, our service is just improved very fast. So we'll have versions like in days or even weeks, we'll have a new version. So we have many versions. And the third one is configuration templates, because for each version, the configuration might be changed. So we need to reference different configuration templates to make sure we use the correct configuration. So that's what we need to have for the service description part in the product. And second thing, for the deployment topology. The deployment topology will describe like how many clusters we need for this product, and how many kinds of clusters we need. And for each cluster, we need to describe what kind of service it needs, and also how to measure the capacity. Just like the elastic compute service, for example, normally we will measure the capacity with the vCPU or vMemory, or this kind of measures exposed to the end users. So we make them as capacity measures. The backend implementation is that we have some automated tool to transform this kind of business measures into the physical measures, like how many vCPU are transformed into how many real servers, like how many IPs or how many network bandwidth we need, just something like this. And another thing we need to describe in the deployment topology is the service deployment topology, because we have different kind of service. In one class, like we have a cluster with thousands of or tens thousands of servers. Different service will be mapping onto the servers with different manners. Like some service will be deployed onto every server in the cluster, but some service only need like 2 or 3 servers in the cluster. And the next thing in the product about features. The features actually we describe here is 2 things. One is deployment requirements. It means if we want to deploy these products, sometime we need some additional products. And we also need to describe how to measure the capacity here for the required products. So that's all concepts for our product. And next thing is about service. I just mentioned the product is composed by services, and the service is actually composed by server roles. The server role is a concept inside the service, so I did not put server role as a separate concept here. Server role means we treat every server as a role. The same, the machines with the same server roles, it will deploy the same software services. And services might have dependencies. Normally, we don't recommend the developers to make dependency between the services because it will really difficult to maintain in the runtime. But still, we have some services have dependencies, so we need a description here to make the infrastructure know which service depends on which service. And the server roles might be in groups because I just mentioned we have deployment topology in product. And for the service, actually, we have a similar concept named server role group. Means we can put several server roles into one group to make sure they will deploy on the same servers. And good example for service is block storage. Because when we use elastic compute service, actually, we have to use block storage, or I should say, most of elastic compute service, we have to use block storage. We will also have the other kind of storage, but block storage is a very good example for the services. And for each service, we'll have server roles. The first thing is the server role types, like for Redis service, we'll have the master role and the worker role. And also the server requirements, because we need to describe what kind of physical requirements the software needs, and also the operating system requirements. And finally, the applications, what is included in this server role. So this is all the things described in server roles. And dependencies, actually in a distributed system, if we have dependencies, they are very complex. Here, I mentioned just two kinds of dependency. One is software service dependency on one node, which means in one server, a server role depends on another. Like, take an example. It's just something like one web application. It needs to access a local configuration file generated by a local service. So this means all these services must be put on one node, and it have dependencies. And another kind of dependency is on a cluster, which means like we have a scheduling service. It will depend on a storage service. They might be deployed on different servers, but all these services must be deployed on one cluster. It cannot across the cluster in this scenario. And for the server role groups, as I mentioned, it just describes how to place the server roles on a cluster. We have different kind of placement method, just like we need to put all the server roles together on one node, or we have to separate all the server roles for different servers. Because let me think about example. We have an example like this. We have one server role named like a tool service. This kind of tool should be deployed on each server on the cluster. We have another service named working service. The working service have to be placed on Intel-based machines in a cluster. So in this approach, we need to describe these things in several groups to place all the things as we want. And finally, for the applications, we have different kinds of applications. At the very beginning, we only have the normal application. The normal application, we just have a binary in the operating system. We can start it. Later, because we have Docker applications, so we provide another kind of application named Docker application. Actually, we have several more applications, but these two applications should be most popular ones. And after we have the artifacts generated for all the services, software services, we need to describe the hardware part. Actually, describe the hardware part is much easier for us because we just model it's just the same thing as the physical world. We have IDC, racks, the networks, the server clusters, like how many servers is included in the cluster, and how about the operating system. Okay, so now what we get is, first, we have an immutable bare metal infrastructure, and second, we can generate the artifacts. The artifacts, actually, we developed a tool with the very beautiful UI for the business people, because business people do not want to use the command line things. So we help them to build a console panel so they can generate the artifacts. And so in our data center bootstrap, the user experience is just like this. The business people use the tool to generate the artifacts. Then we burn the artifacts in a CD, and the delivery people just get the CD and push the CD into the first server, and it will initialize the first server. The first server connects to the network, connects to the management servers, and connects to the several other management devices. Then it will initialize everything. And after the management panel is initialized, it will automatically bootstrap all the other things in the data center. So with this kind of method, we start from the first data center with 2 months. And this year, actually, most data centers, we have the bootstrap phase in 24 hours. I think we only have several difficulties, like we extend this time to about 72 hours, but mostly we can finish everything in 24 hours. And we also provide this kind of technology in our products, which is the Apsara Stack from Alibaba Cloud. It is a dedicated cloud offering from Alibaba to deploy cloud services in customers' data center. So this is what we provide for the business people. So let's go to the summary. So I want all the people here can get is, first, to build an immutable bare metal infrastructure, actually we need to think about 3 things. The first thing is we need to make the controller as a state-driven controller. It is not that difficult because you can just think about in our state machine, we only have 5 or 6 states in our state machine. So you can just think about how to build the state machine. The second thing is how to describe everything with state-based configuration files. And the third one is make the image-based deployment against the traditional workflows. And the second thing is how to describe the data center. Normally, it is easy to describe things for hardware parts because we can just model everything just what we have in the physical world. And the difficult thing is for the software services. So here I just gave an introduction about how we did the work in our approach. Okay, that's all for my session. Okay, thank you.